2024 turned out to be an incredible year for both image and video models. Honestly, at the start of the year, I didn't think we'd get much at all, but it just kept surprising us as things got better and better. Today, we're talking about one of those models, Hunyuan. Before we get started, if you find this video helpful, please take a second to like and subscribe. It's honestly such a boost knowing someone out there is enjoying the content. It keeps me motivated to keep creating. Today's workflow is made up of 6 main groups: the loader group, the image to prompt group, the video to video group, the image to video motion guide, the conditioning and save group, and finally, the upscale and frame interpolation group. Let's break down what each of these groups do and how they're set up so it's clear before we jump into using them. The loader group is where everything starts. It's built around a few key components: an index switch, a quantized model loader, and a diffusion model loader. The quantized model loader is what loads the GGUF model, and for the diffusion model, I'm using the fast FP8 model. There's also a dual clip loader, which is set up with the improved clip L that I've used before with Flux, and the Lava Llama 3 quantized model. Along with that, we're using the Hunyuan Video VAE. This loader group is what gets all your models and resources into place. For the image to prompt group, I'm using a Florence 2 node because Hunyuan doesn't yet have a proper image to video model. For this, I'm using the COG Florence 2.2 large model. It's great because it can automatically take a given image and turn it into a video prompt, which makes things so much easier when you're just getting started. Next, let's look at the conditioning group. This part is made up of the prompt sampling and save groups. The prompt section includes a switch that lets you choose between writing your own prompt or using the Florence generated prompt. To improve video prompts, I've added the Hunyuan Video Styler here. For sampling, I've simplified things by including a K sampler. There's another switch in this section that allows you to choose between 3 options: an empty latent, the video to video option, or the image to video motion guider. At the end of this group, there's a tiled VAE. I've set it up with a tile size of 128, an overlap of 32, and a temporal size of 32 with a temporal overlap of 4. This is followed by the video combine and video comparison nodes, which come into play later. I've set my frame rate to 24 frames per second for the workflow. The video to video group is where you'll upload a video, resize it, and then feed it into the K sampler through the VAE encode. There's also an image concatenate node in this section. It takes the uploaded video and the generated video and feeds them both into the video comparison node. This setup is key for seeing the differences or improvements in the final output. Next, we have the image to video motion guider group. We'll get into the details of how it works when we actually use it later on. Finally, we've got the upscale and frame interpolation group. This is one of the easiest ways to upscale a video without using a ton of system resources. It works by upscaling each frame individually and then adding extra frames to smooth out the final video. It's efficient and doesn't demand much from your hardware, which makes it a great option. Now that we've got an understanding of the workflow structure, let's focus on how to prompt for Hunyuan effectively. Think of prompting like giving instructions to a director and film crew. You're not just saying, make something cool. You're guiding every detail: who the characters are, where they're standing, what's happening in the scene, and even the mood you want to convey. The more specific and thoughtful your directions, the better your final video will turn out. First, you need a subject focus. This is the main character or object in the scene. For example, it could be something like a girl, a ghost, or a soldier. Next, think about the setting. This is the environment that anchors the scene. Maybe it's a winter garden or a dimly lit attic. Then add some action or emotion. This gives movement or feeling to your scene. It could be as simple as strikes a match or rushing down a staircase. After that, include details. These are the small but important things that make the visual more specific and believable, like red hoodie or golden dunes. You'll also want to establish the mood or tone. Is it mysterious? Whimsical? The tone shapes the overall aesthetic and vibe of your video. Framing or shot type is another thing to consider. Are you imagining a close-up, a wide-angle shot, or something else? Finally, don't forget imaginative touches. This is where you can get creative. Maybe you add something unusual, like a panda riding a bicycle or melting ice castles. To test this out, I used the following prompt: a cinematic scene, a samurai in dark blue and gold armor holding a samurai sword, slowly walking in a tranquil forest, golden sunlight filtering through the trees, wide-angle shot, eye level. Let's break down how those 7 elements are used in this example. The subject focus is the samurai, described in detail with his armor and sword. The setting is the tranquil forest, which sets the mood for the whole scene. The action is slowly walking, which adds a sense of calm, deliberate movement. The details, like the colors of the armor, ground the visuals in historical and cultural specifics. The tone comes through with the golden sunlight, which creates a peaceful and almost ethereal atmosphere. The framing is a wide-angle shot at eye level, which gives a cinematic feel. And the imaginative touch. That's the golden sunlight filtering through the trees, which elevates the scene visually. On paper, this prompt looks great. It seems like it should produce something vivid and detailed. But when I ran it through Hunyuan, the results were disappointing. Here's where the model starts to fall short. If you look at the examples on Hunyuan's website, most of the prompts are incredibly simple. For instance, one example is just a close-up, a little girl wearing a red hoodie in winter strikes a match. The subject is clear. It's the little girl in the red hoodie. The action is strikes a match, and the word winter gives you the atmosphere. Another example is, in the gym, a woman in workout clothes runs on a treadmill. Again, the subject is the woman in workout clothes, the setting is the gym, and the action is running on a treadmill. Even with minimal input, Hunyuan fills in the gaps to create a cohesive video. But here's the thing, when you try to add just a little more complexity or specificity to these prompts, the results often fall apart. That's exactly what happened when I tested the model. Instead of improving, the videos became less coherent. Next, let's look at how to use the video styler node to make things a little faster and easier for you. But, and I can't stress this enough, you really need to keep your prompts simple. Stick to somewhere between 100 and 300 characters. The node itself gives you a ton of options like movie scenes, time of day, weather, lighting, camera angles, composition, effects, video styles, and cinematic color. It's a lot, right? But just because you can use all of these doesn't mean you should. Let me show you how I use this node without overcomplicating things. I always start with 2 basic elements, the subject and the action. Let's say I want to create a video of a car drifting around a corner. The subject is the car, and the action is drifting around the corner. Even if I stop there, Hunyuan would generate a pretty solid video. But let's try adding just a little more detail. Not too much, because this model really struggles when the prompt gets overly complicated. For this example, I'll choose a well-known movie scene to set the tone. Let's go with Mad Max Fury Road. To make sure the scene is easy to visualize, I'll choose high noon for the time of day. That gives us bright, intense lighting, which fits perfectly with the Mad Max vibe. I'm going to leave the weather and lighting options alone, because I feel like the time of day already covers those details unless I'm going for something super specific, like a rainy or foggy setting. Next, I want the camera angle to feel slightly unsettling, so I'll go with a Dutch angle. If you're not familiar, that's when the camera is tilted, creating a sense of tension or chaos. It's a classic technique, and it works well here. Since I've chosen a Dutch angle, I don't want the shot to feel overly centered or symmetrical. To balance things out, I'll use the golden ratio for composition. This creates a more dynamic and visually interesting layout without making the shot feel too chaotic. Finally, I'll pick a video style to tie everything together. For this one, I'll go with sports action. It's a high-energy choice, and it should complement the fast-paced feel of the drifting car. At this point, I'm honestly pushing the limits of what Hunyuan can handle. We've got the subject, the action, a movie-inspired setting, a specific time of day, a dramatic camera angle, balanced composition, and a dynamic video style. That's already a lot of information for the model to process. But let's see how it all comes together. Before we generate anything, I'll make one small tweak. Instead of just car, I'll specify sports car. And to keep things consistent, I'll use the quantized models for both the checkpoints and the dual clip models. I'm leaving the steps at their default value of 20, so there's nothing extra you need to adjust there. Let's look at the prompt the video styler gives us. A sports car drifting around a corner. Post-apocalyptic desert wasteland, rust and chrome aesthetic, diesel punk environment, savage vehicle, filled landscape, extreme desert setting. Overhead sun position, minimal shadow length, maximum light intensity, vertical light rays, noon contrast ratio, tilted horizon camera position, diagonal frame alignment, sideways rotated perspective, canted angle. Fibonacci spiral composition, 1.16 ratio divisions, golden section alignment, logarithmic spiral organization, dynamic action progression, athletic sequence flow, momentum-based timing, energetic movement evolution, competitive rhythm. This looks like a recipe for disaster. But let's not write it off just yet. Let's see what Hunyuan gives us. I wasn't expecting that, but it looks pretty good. Everything I wanted is basically there. The sports car drifting through the desert, the overhead sun, the sideways, tilted perspective. Even the camera with that angled horizon. This is a great example of what Hunyuan's text-to-image feature can do when your subject is straightforward and the action is clear. Everything else, like camera positions and movie scenes, is just extra. You've probably noticed that the videos we've created so far are a bit low quality. That's because I've set the resolution at 360p. We'll get to upscaling them later. Next, I'm going to enable the video-to-video group. This includes nodes like upload video, resize image, get image size and count, image concatenate, and VAE encode. The image concatenate node is there for video comparisons. It lets you compare the uploaded video with the new, generated one, side by side. First, I'll upload the video I just created. Then, I'll simplify the prompt, since this new video will be driven by the one I'm uploading. The new prompt will be something like a powerful off-road truck drifting through the mud. I'm also going to disable all the additional styles. That's because we're using a video to drive the generation, and adding too many details can create unnecessary conflicts. I'll also make sure my resized resolution matches the latent width and height. I'll change mine to 6040 by 368 to match the latent dimensions. I'm keeping the start frame at 0 because this video is short and starts exactly where I want it to. But if your video is longer, like let's say there's a part where people are standing around and talking, but you want to skip to the action, you can adjust the starting frame. This lets you choose where the video begins. Similarly, the frame load cap stops the video at a specific frame. If you only want to include part of a video, you'd use the start frame to set where it begins and the load cap to set where it ends. I'll switch the latent switch to 2 for the video to video latent setting. To speed things up, I'm going to use the fast video model and drop the steps down to 8. The native implementation doesn't seem to work as well as ComfyUI's wrapper. At best, it takes a single frame from the input video and uses that to drive the output, or it just ignores the video altogether. The only way I got results even close to what I wanted was by keeping the prompt mostly the same and only changing the subject. Another thing I've noticed is that the fast Lora gives a better result than the fast model. I'm going to use the fast Lora to test the image to prompt group. I'll add the power Lora node, select the Lora I want to use, and leave the weight at 1. Then I'll switch the model to the quantized model by moving the switch to 1. For the image to prompt group, I'm using the COG Florence 2.2 large model. It's a solid choice because it doesn't just describe the image. It also adds a sense of movement to the description. The prompt switch needs to be set to 2 for the large language prompt. Since I'm using the fast Lora, I'll also adjust the steps down to 8, and for the latent switch, I'll set it back to 1 for an empty latent. The prompt it generates is really detailed, a vivid portrayal of a person walking through a lush, green urban environment. The person, facing away from the viewer, wears a grey t-shirt and carries a black backpack with a yellow logo on the front. The backpack has a rectangular shape and appears to be made of a durable material. Lush greenery surrounds the person, with tall, multi-story buildings featuring balconies and windows. A single orange flower blooms on the right side of the image, adding a splash of color to the scene. The image's color palette is dominated by greens, browns, and the bright orange of the flower. The overall mood is serene and contemplative with a hint of nostalgia. I think the quantized model paired with the fast Lora gives much better results than the fast video model. We'll dive deeper into using Loras later, but for now, this looks pretty solid. Next, I'm enabling the image to video motion guider. This group includes an image motion guider node. The image motion guider node in ComfyUI is such an interesting tool, especially when you pair it with Hunyuan Video. Its job is to take a static image and create guided motion effects, which makes it a great pre-processing step for AI-generated videos, at least at times when it actually works. Essentially, it works by tweaking the latent space, the compressed representation of your image to guide motion patterns in the video. To start, make sure you've got the image you want to use loaded into the workflow. This is done through the image loader node, where you also set the resolution of the image. I'm going with 640 by 368 for this example. Now let's quickly look at the motion guider node settings. For horizontal movement, you'll use the Move Range X setting. I'm setting mine to -50, which will create motion to the left. If you want motion to the right, just use a positive number. Then decide how long you want your motion sequence to last. I'm going with 73 frames, which gives me about 3 seconds of video. If you're unsure, you can always increase it in increments of 24 frames. Each increment adds roughly 1 second. For zoom, I'm leaving it at 0 since I don't need any zoom effects here, but you can add it if you want a dynamic perspective change. Next, we move on to the VAE encoder node. This step converts the output of the image motion guider into latent space, making it compatible with Hunyuan Video. Since I'm running this on a system with 8 GB of VRAM, I'll keep the VAE tile settings as low as possible to avoid overloading my system. Adjust this based on your setup. You'll still need to add a text prompt to guide the style and content of the video, but the image motion guider will handle the motion. For my prompt, I'm going with something like, a tall man wearing a blue jacket strolling through a bustling, futuristic metropolis. Notice how I'm keeping it specific. The subject is the man, the action is strolling, and the location is the futuristic metropolis. I'm also setting the time of day to mid-morning and the video style to indie film. These choices help define the scene without overcomplicating it. Before you hit Q, double-check everything. Make sure that the switches are correct. 1 for the quantized model, 1 for your text prompt, and 3 for the image motion guider. Oh, and don't forget to set the steps to 8 since we're using the fast Lora. The generated video should show a man strolling to the left in a bustling cityscape with that indie film aesthetic. The mid-morning lighting should add a nice touch with defined shadows and overall warm tone. I want to mention that while this node has worked for me in the past, it's not always perfect. Sometimes the motion direction doesn't turn out as expected, or the style doesn't fully align with the prompt. For instance, if the man ends up walking to the right instead of the left, it might mean I missed something in the setup. Or it's just the node doing its own thing. Either way, it's worth experimenting. Even when things don't go as planned, you might discover something unique that works for your project. Give it a try and see what results you get. This node opens up so many creative possibilities, and while it's not flawless, it's definitely a tool worth exploring. Let me know how it works for you. The final group we're looking at is the Upscale group. This one's pretty straightforward, but super useful if you want to enhance the quality of your video. It includes 2 key components, the Load Upscale node. There's also a switch that lets you choose between uploading a video or directly passing the video you've just created into the Upscale group. The Interpolation options has 2 nodes, GMFSS, which works best for animations, and RIFE, which is ideal for realistic videos. All you need to do is connect the node that fits your project to the video combine node, depending on whether your video is animated or realistic. For this walkthrough, I'm going to use the RIFE interpolation because I'm working with a realistic video. The models for these nodes download automatically, so you don't need to worry about hunting them down or installing them manually. Let's upload a video and walk through the settings. I'll use the video of a racing car as my example. First, make sure you set the switch to 2 to enable video input. For the upscale model, I'll go with 4x Ultra Sharp, which is fantastic for maintaining crisp details. The upscale method is set to Lanczos by default, and I'm going to leave it there because it works well for most projects. You can adjust the upscale width and height to whatever resolution you want. I'll keep mine at 1920 by 1080 since that's a standard size and fits the content I'm working with. At this point, if you're happy with how things look, you can stop right here and export your video. But if you want an even better result, continue with interpolation to enhance the smoothness and overall quality. Interpolation effectively doubles your frame rate by adding new frames between the existing ones, making the motion much smoother. I've found that the best approach for this group is to first interpolate and then upscale. Before you queue, remember to bypass any groups that aren't in use. This ensures you're only working with the active nodes and won't accidentally apply unnecessary changes. Once everything is set, let's queue it up and see how it looks. The result here is surprisingly good. It processed faster than I expected, even compared to the video inference stage. I'm going to try another example to show you the difference more clearly. In the first stage, each frame gets upscaled individually using the model you've selected. Then in the second stage, more frames are added to the video, creating a much smoother output. The combination of these two steps really elevates the final product. This brings me to what I think about this native implementation, especially compared to ComfyUI's wrapper for Hunyuan Video. Honestly, it's a mix of good and bad. The output quality is undeniably beautiful, and I love that it supports Loras. You can customize video styles in the same way you would with image generation models like Flux and Stable Diffusion, but it's not as precise as I'd hoped. For instance, I haven't tried the prompt rewrite model yet, and that might help refine the results to better match my prompts, or at least get closer to what I want. There are a few limitations worth mentioning. One of the biggest is that there's no image to video feature yet. And then there's the time it takes to generate a decent video. Even with the fast video model, 8 GB of VRAM isn't really enough to handle this effectively. You'll likely run into errors if your setup is underpowered. For anything close to a smooth experience, you'll need at least a 12 GB graphics card. Generating a single video can sometimes take up to an hour. Even with the quantized model, it's not exactly quick, and that's something to keep in mind if you're planning on using this for larger projects. Here's a quick comparison to wrap this up. ComfyUI's wrapper for Hunyuan Video has some big advantages, like being more accessible. It also supports negative prompts and lets advanced users customize how prompts are rewritten for better control over video generation. But that added control comes with a steeper learning curve, so it might feel a bit overwhelming for beginners. The native implementation, on the other hand, is much more streamlined. It's designed to fit seamlessly into the ComfyUI workflow, so it feels intuitive and well integrated. It's officially supported, which means you'll get regular updates and compatibility improvements. However, it does require more VRAM, and while lower VRAM options are available, they can compromise quality. For most people, the native implementation is going to be the better choice. It's easier to use, comes with official support, and integrates seamlessly into ComfyUI. If you're looking for something straightforward and future-proof, this is the option to go with. That said, my personal preference is ComfyUI's wrapper. The reason for my preference is the control I get when using it. Now, are either of these methods truly production ready? For me, it's a no, because I use image to video, but with a speed boost like the wave speed node, it might be feasible. But to be honest, Hunyuan is a 13 billion parameter model that wasn't meant for consumer-grade setups. The fact that we can even use it is amazing. Use it if you have a beefy system, or if text-to-video is your thing. The native implementation is a big step forward, but you're still restricted to short video lengths, just a few seconds, and you'll need significant computational power to get high-quality results. It's not perfect, but it's definitely exciting. Now that we've covered the basics, let's dive into setting this up. And the good news is it's pretty straightforward since this is a native implementation. The first thing you need to do is make sure ComfyUI is updated. To do that, open the ComfyUI Manager, click on Update All, and then restart the program. Next, we have to download the models. You've got a few options here. You can grab the base model, the FP8 version, or the fast video model. All the download links are in the description below. Start by clicking the link for the version you want, whether it's the base model, the FP8 version, or the fast one. Once the file is downloaded, you'll need to move it into the correct folder on your computer. Specifically, place it in the Models Diffusion Models folder within your ComfyUI directory. Grab the quantized model from the link in the description and move it into the Models UNet folder. If you've used Flux before, you can stick with the same clip-L text encoder. There's also a link in the description for the Lava Llama model. Download it and save it in the Models clip folder. For the VAE model, there's another link in the description. Download that file and place it in the Models VAE folder. Finally, you'll need an Upscale model. This part is actually super simple. Open the ComfyUI Manager, go to the Model Manager and search for 4x. Once you've found a model that works for you, go ahead and install it directly from the manager. All that's left now is to drag the workflow file into ComfyUI, and you'll see a series of nodes appear. If you see any missing nodes, open the manager again, click on Install Missing Nodes, and then select the nodes you see listed. Hit Install, and the manager will take care of the rest. Most of the nodes will automatically download the models they need, so you don't have to do anything extra at this stage. Try the workflow and let me know what you think. You might absolutely love the results, or maybe it's not quite what you're looking for. Either way, it's a powerful tool to experiment with. Thanks for watching, and if you found this helpful, make sure to like, share, and subscribe for more tutorials. See you in the next one.